in the heart of the urban jungle, a unique species of Homo sapiens thrives. Identified by their common adornments, the humble hoodie, their peculiar yet endearing rituals involving ping-pong tables, and an astonishing amount of free coffee. The startup Homo sapiens.
I'm no David Attenborough, but I know a thing or two about startups. For example, did you know they don't run on coffee alone?
I'm here to guide you on an extraordinary journey. Our new Twitch series, AWS Let's Build a Startup. Together we shall observe how an idea evolves, grows and matures into a real minimum viable product. All of this within the AWS ecosystem. Whether it's the thirst of knowledge guiding you or simply your passion for free caffeine. Join me on this fascinating journey.
Hey, hello folks, and hello founders. Welcome back to AWS Let's Build a Startup. This is your 1-hour show that weekly takes you through the secrets and the mechanisms of success that we've seen on awesome startups that are building with us on AWS. I'm Giuseppe Battista, I'm your host for today. And in store for today, I think we have a great episode. We're going to dive a little bit deeper on what small language models are, how startups can actually make use of them, and what is their role in agentic AI. To do that, I have two exceptional hosts with me. I will be introducing them soon to the stage, but please folks, let me know if you have any question about small language models and what they are, how we can use them if you're already using it into your startups. Before we dive deep into the world of small language models, let me just remind you of a few new episodes that are coming. So a few weeks ago, actually, we had a fantastic episode with Lovable. We'll be sharing a link to that episode in a few moments. But next week, for example, we will take you through the journey from dataset to actual inference and production with two of my favorite startups and actually AWS partners. So we will have Super Annotate and Fireworks AI, and we will take you exactly through the journey of from gathering your first piece of data, adding labels to it, automating the process of adding labels, all the way through actually have production ready endpoints. But without further ado, I really want to welcome to the stage Julien Simon from Arcee and ex-Gameface and ex-AWS, a former colleague, and then my friend and colleague Nicolas David. Hey folks, how's it going? Nicolas is a startup specialist like myself, but I'm based in the UK. Nicolas is based in Bahrain, and you are working with Sub-Saharan Africa. So I'm super eager to learn more about the stories from startups there. And Julien, I don't think you need any sort of introduction. I'll just do that for the sake of it because I really like the sound of my voice. So what I think you're a pillar of the open source community when it comes to AI, and the same voice and the same voice that keeps us absolutely
that I am trying to be, yes.
So yeah, folks, I know that you have been exposed to small language models in a way or another. Julien, I know that you have bought almost completely into the idea of simplifying our approach to large language models. But I really want to hear from you folks. So I want to spend maybe the first couple of minutes on the show, maybe helping me understand what is a small language model and how are we going to use it, and what are the difference maybe with large language models.
So I'll start, and you can correct me, Nico. Okay. So small language models are small compared to large language models, right? How about that for an introduction? So large language models are basically the models we started working with when ChatGPT came out, right? Those are the models that everybody listening to us right now would know and be familiar with. So very large models, increasingly large models, even hosted behind APIs, and generating text, generating images, etc., etc. So that's how it started, and we tend to call closed language models as well, because we don't really know what they are. They're hosted behind API. We really know what they've been trained on, etc. So a black box element. And a few months after those models the open source community started releasing their own flavor of language models, right? And obviously Hugging Face played a very, very important role there. So we started seeing models from US universities and pretty soon from startups and then from Meta. So, and now again, everybody's familiar with the llamas and the Mistrals. And I guess we'll talk about Arcee later on. And those models are definitely smaller than their I would say their close equivalents. So even though if you read research papers, funny enough, you will still see people saying LLMs, and then they'll use llama or Mistral or something else. They'll be working with models that are way smaller than the bigger ones. And again, we don't know what we don't know, but if we assume that the largest models from OpenAI and Anthropic, etc., are hundreds of billions of parameters, maybe even trillion, maybe several models collaborating. Obviously, those small language models are much smaller. Llama. A lot of folks out there use Llama 3, 8 billion, or Mistral 7 billion. Arcee released a few weeks ago a 4.5 billion parameter model that is actually better than the 8B model from Llama. So I would say now we live in a world where you can work with single-digit billion parameter models and get real work done, not just not just toying around, not just working, experimenting, but actually deploying enterprise use cases and getting business value from there. And I think so that's why we should really all try and say small language models now. And yes, I know there are larger open source models. We have models. OpenAI, funny enough, finally released an open source model again, and it's 120 billion. So you could say, okay, that's that's a larger model. So maybe that still qualifies as an LLM. But I think when we say small language models, we really mean models, 10 billion, 20 billion, nothing really bigger than that.
Okay, so it's about initially with the number of models, right? And how about your opinion, Nicolas? What do you think about them?
Yeah, no, I 100% agree with Julien. I think Julien was one of the earlier advocates, if not the only earlier advocate of small language models when I first met him in his role. You were the loudest, probably, yes.
Maybe not the first,
and so,
but probably one of the loudest, yes.
and so recently, so as you mentioned, Giuseppe, I cover Sub-Saharan Africa with early stage startups, and one of the customers I've been working with recently, based out of Johannesburg, called Le Lapa. We presented actually in the summit a couple of weeks ago about the model that they use, and they have actually released a model called Incuba LM, and it's a fairly small model. It's 1.9 billion parameters, and it covers 5 languages. So this model, covering 5 languages, is basically translating, let's say, from Zulu to English or to another, African language, back and forth. So the idea behind this is to sort of remove barriers in education and several other commercial use cases as well. Fantastic use case, yet a small language model is used, not something with, as you said, 120 billion parameters. So fantastic example of what can be done with these models, these SLMs.
So it's not just capabilities.
Yeah. Oh, sorry, Giuseppe.
No,
just
no
a quick
worries.
mention. So this is a really good point, and I've keep if you're listening to me from time to time, you keep hearing me. Models get smaller and smaller, yet they get better and better, and that's a really important point because I said our 4.5 billion model is better than 7B or 8B models from, let's say, 6 months or a year ago, and that trend will continue. So I don't think we need additional buzzwords, but I start calling them crazy small language models, CSLM. Because now we're seeing 3B or even smaller, like the one that Nico mentioned, models that are very, very capable, and of course they won't have all the knowledge and the abilities that bigger models would have, but they get, again, if you focus them on a single job, if you optimize them for that job, they will work great, right? They will work great. So I think that the first thing I want to make clear is there's been a lot in the last few years. There's been a lot of focus on parameter count, and a lot of folks out there want you to believe that bigger is better. That if you want to get more ROI from your model, you need a bigger model, whether open source or closed source. That's not true. The 70B models from a year ago are obsolete, and you can certainly get as much performance today with maybe a 8 or 9 billion parameter model. So you really need to focus on what you're getting from models today, and not, oh, this is a big model or this is a small model, or the size is really the size with respect to the abilities. That's a very fast moving target, and from 1 month to the next it will literally change. So don't be afraid to test the smaller models, the latest smaller models. I mean, Hugging Face, as you know, the small LM and model, etc., and those are very good models too. So you should really try them out. You will be surprised how much value you get from there.
Oh, I get you. So, so that kind of association between like number of parameters and let's say capabilities in general, that kind of goes out of the window as we are progressing into like maybe enhancing the way we're training these models. Is that the takeaway from here?
Yes, the short answer is it's all about the quality of the data, and of course the improved training techniques. But if I have to pick one thing, it's the quality of the data, and we saw that when we trained our 4.5 billion parameter model, which is called AFM 45B. I'm sorry for the jargon. AFM means Arcee Foundation Model. Okay, that's simple enough. And we saw that when we were monitoring the progress of the training job and running evaluation on the early checkpoints, we could see already that the early checkpoints were outperforming some of the better models out there. So so literally the curve was skyrocketing, and delivering very early on super strong performance. Because of course, I guess we know what we're doing, and our training recipes are not too bad, etc. But it's really the quality of the data. It's the quality of the data. If you're in school, you can have an amazing teacher, but if the material sucks, if your manual sucks, if you don't work on the right exercises, if you don't practice on the right stuff, you won't really learn. So you need the right teacher, you need the right recipe, but more than anything, you need the right material. And this is why those models are getting awesome very quickly.
So I've shared a link on LinkedIn. I will be sharing on YouTube and Twitch pretty much soon. But if you want to have a look at that, there's a link. I think it's to the description page to your model card. But we do have a few questions that are coming from YouTube.
Yeah,
Our friend Vivek. Hey Vivek,
yes.
Thank you so much for your questions. So can small language models, they can be a game changer for edge deployments, where we basically need offline intelligence in near real time. What do you think about that, folks?
Yes. I saw you on LinkedIn a lot, Vivek, so that's good. Yeah. Actually, again, if you think about what I was saying earlier, which is the models get smaller and smaller, yet better and better. It's a very positive flywheel. We love flywheels. And now we're getting to a point where the models are so small that you can optimize them for edge platforms. So let's say a CPU platform, a server running in a in an edge location, in a restaurant, or in a I don't know, a gas station, whatever you want. Or it could be even a smaller device than that. And they're so small already, and through further quantization, optimization with frameworks like Intel OpenVINO, or for Intel platforms, or Llama CPP for more platforms, you shrink the model further. And because those modern CPUs, and I guess we'll do some demos later in the session actually on that, so hang around if you want to see CPU inference. You get really great performance because you have hardware acceleration on those CPUs, etc. So I'm if I'm noisy about the one thing, it's really SLMs plus CPU. I think this is really an amazing combination. A lot of us are running those things on our laptops. We don't have GPUs. You can run them on the plane. You can run them anywhere. It just works. Nico, did you have some experience doing that?
Yeah, actually, back when SageMaker had this other service called SageMaker Neo, you could actually compile a model specifically for edge devices like a Raspberry Pi. And then fast forward that a few years down the line, and I think it was last year or a couple of years ago, the Raspberry Pi comes now with an AI hat where you can have up to, I believe it's 26 teraops of performance.
Yeah.
And so if the model is small enough, if you have those CPUs or dedicated chips, we can speak about, Inferentia, Trainium, things of that nature, then you're able to do lots of things without a GPU. And even at the edge with this Raspberry Pi AI kit.
Raspberry Pi is based on ARM, right? It's an ARM core. And I'm doing a lot of work with ARM. And as we know, also, of course, the Graviton CPUs are ARM-based, and all those chips have the instruction sets that you need to accelerate. Different generations may have different instruction sets, but generally, ARM is putting a lot of effort into adding those acceleration instruction sets for matrix multiplication and all that good stuff. And it makes if you combine that with, let's say, Llama CPP, for example, which is probably my favorite open source project right now. It's a great combination. And again, if you move from an 8B model to a 4B model to a 2B model, you just get and maintain the level of, let's say, business performance. Then you just get maybe twice the speed or twice the throughput, or whatever metric you're after. On a tiny platform that is super cost effective, that can run outside of the cloud, that can run almost anywhere. This is really nice.
Yeah, and I guess this goes into the maybe answering the question that Bhavesh has asked us. Would you recommend small language model for IoT applications with low resources? And I've only heard good stuff about this in terms of IoT. Is there any reason why we should maybe shy away from this and still keep some of the inference back in the cloud?
So I've done embedded in my life. Everybody has their own definition of it, right? So I would say right now, anything smaller than a Raspberry Pi is probably not a good idea. If you're so Bhavesh, you're mentioning ESP32 or like small 16-bit microcontrollers. No, I think that's not reasonable. You could probably run small computer vision model, etc. But you could not run generative AI models. But again, IoT means a lot of different things to a lot of different people. Some people are running NVIDIA platforms at the edge, Jetsons, etc. And those are small GPUs, and of course, you can look at them. But don't get me wrong. You won't be able to run a text generation transformer on a 16-bit Atmel or chip anytime soon. So that's
that's
the limit. but yeah, I think IoT and generally Gen AI at the edge has a lot of interest. And a scenario we're seeing is just turning machine data or technical logs or whatever complex data is generated or received at the edge into natural language text, right? Like think predictive maintenance. You can write an email automatically. You can shoot an email to a technician. You can generate a failure report right at the edge. You can generate a daily report of, okay, this is working, this is not working. So you can do it right there, and that's so much better than just having to go through logs. I mean, we've all done that, right? Like trying to debug things, going through logs. So imagine showing up at the technical location somewhere in the middle of nowhere and being able to chat with the system installed there and figure out what's going on, instead of having to open technical logs and debug things with outdated diagnostics, etc. So yeah, there you can think of a lot of scenarios there.
Yeah, so Bhavesh was suggesting edge processing, for example, for smart meters analytics. That's fantastic. Or another use case, which is
sure.
Preventative maintenance.
Decoding,
get
those models are great at understanding very complex data and turning it into plain English or plain whatever your language is.
Yeah. I think that's the other surprising, but it's not only because of the capabilities of like translating to languages, but it's also because of I would say maybe the need of or like smaller corporal data to actually train this, because if now we're shifting our attention from quantity to quality, then it means that we can like build this knowledge, let's say these models that are embedding or abstracting this knowledge, abstracting ways of thinking for languages that don't have such a like, let's say, extended literature, like they're normally or culturally the heritage was not passed down by writing, right? So I'm thinking, Nicolas, the type of languages that your customers are more accustomed to.
I want to also mention something that happened very recently, and I think many people spoke about this from AWS, but specifically what happened in Madrid, where the whole city was out of electricity, right? The infrastructure kept on running, but there was no way of interacting with things. So if you think about scenarios where you need to manage traffic, in a smart city environment with intelligence at the edge, you're able to sort of manipulate the traffic lights to make the traffic, I would say, as smooth as humanly possible or AI possible. Then there's plenty of scenarios that are in this domain where, in this case, it was no electricity, but there's still sun. It could be rural areas where connectivity is not that great, or you need satellites, things of that nature, right? And so smart city and very specifically in smart city, one of the things that I really, really like is the concept of living digital twins, right? So something that's around all of this data that's collected by various types of sensors. If you're dealing with this data at the edge, you're saving on latency, you're saving on a ton of things. So super interesting things to do. And thanks to SLMs, you're able to deploy this on hardware that doesn't consume tons of electricity.
Yeah, that's a very interesting use case, I think, and as we are building these systems, and like potentially culturally, we'll be starting relying more and more and more onto this system. It's great to think that we have like a default option onto maybe our local inference compute. But there was a very, very interesting question coming from Bruno from LinkedIn. Hey, Bruno, thank you so much for that question. Can we execute an ephemeral environment for small language models in a Lambda and FS3 to persistence? So, I mean, I love that kind of architecture. Any suggestions here? I'm just thinking about
There's no reason not to. If you understand the compute restrictions that are synonymous with Lambda, right? So no GPUs in Lambda. And again, we don't know what we don't know, but it's fair to say Lambda does not have the latest CPUs. So now you could select. There's actually a box if you work with a console, but you can actually select between AMD. I guess Intel and Intel/AMD or ARM. Something tells me it's not the latest Graviton in there. So, but what do I know? And that means all the goodies that you will see later in the demo and the hardware acceleration that I was mentioning is probably not available there. So, having said that, yes, you could absolutely do that. I would recommend trying, just Llama CPP with the Python API, or and just grab a model and just go. You have to worry about cold start and all that good stuff.
I'm thinking of transferring data from S3. Maybe might be a bit.
I try to make sure not every single Lambda function copies the model from S3. That kind of stuff. But I mean, you should know the tricks by now, right? Temporary storage, and there are good blogs on how to do that.
Yeah.
But technically, I mean, technically, it's possible. It's just that, again, you're not working with the latest and greatest CPUs, so it's not going to be like unit performance is not going to be great. Then again, if you have 1,000 parallel invocations, which is easy to do with Lambda, this could work for your use case. So for use cases where you need very low cost and you're not sensitive to latency and you need lots of parallel invocations, maybe batch processing, etc. through Lambda, why not? That could be very nice. Yeah.
Mm-hmm. I'll just pop up this last question, and then I swear we're going to a demo. I know you folks are absolutely craving for it. So let's take this one. Any ideas of the cost of training as a small language model? Is it something that maybe not just the cost, but what are the dimensions of cost of this? And because I'm pretty sure that this is a complex thing, right? We cannot just say $3.
No, you can't. I wish, but you have to define what training means to you. So to keep the discussion short, if you're talking about training from scratch, okay, so you want your very own SLM trained completely from scratch on your own corpus of data, I'll be honest, we're still talking millions of dollars, okay? And preparing the data will be the worst part of the project. Training is actually not. People are going to jump on their chairs, but training is actually not the hardest bit. The data is the killer, because again, I said the end quality of the model is really linked so much to the quality of the data. So now, if we're talking about fine-tuning or post-training, as we prefer to call it, so starting from one of the good Hugging Face models out there, okay, maybe ours, why not? Okay, you start from AFM 4.5b, and you want to specialize it for a particular use case. I don't know. Let's say you work in financial services and you want to build a customer support chatbot, etc. Now, if we're talking about fine-tuning it, the cost is much more reasonable because the model has already been trained on 99.99% of the knowledge, and you just want to add a little bit more. So it could go from a few $1,000s to a few tens of thousands, depending on again the model size and how many runs you're going to need to get there, etc. But it's orders of magnitude simpler, and Arcee does that, by the way. So that's one of the ways we make money. So if you're interested, you can ping me and I can connect you to the right people. But generally, those are the numbers.
And so the recipe is pick a good open source model, fine tune, and then get started from there, because you don't want to redo the full like heavy lifting over creating a model from scratch. Not
and
in
I see there's
2025.
there's a good follow-up question here on fine-tuning is susceptible to catastrophic forgetting, and that's absolutely right. And not to be cheeky or anything. This is why it's not that easy to get fine-tuning right. And catastrophic forgetting means, for folks who don't understand here, this is what this means is you're training the model so much on your own use case. So let's say customer support chatbot for banking, okay? That it only knows how to do that, okay? Everything it could do before is gone, okay? So again, if you imagine doing 3 months of linear algebra, and then trying to switch back to Greek philosophy, well, you'll have a hard time, because you fried your brain on linear algebra, and Greek philosophy is gone. So that's the analogy, which is why I prefer to say post training, because there's much more than fine tuning out there. Techniques like model merging, model distillation, which again Arcee has shown to be pretty good at, are proven ways to enhance models, add knowledge or behaviors to models in a non-destructive way compared to fine tuning. So that's fine tuning is a blunt tool, and yes, it can damage your models. Merging and distillation are scalpels and and neurosurgery tools.
Yeah. Oh well, love that analogy. But how about we've been chatting for half an hour, which I believe it's a record for this show, because we try to grasp the attention of the viewers with nice demos. So while maybe you're bringing up your screen,
let's do
Julien, so I just wanted to make a few announcements again. So folks, you're watching AWS Let's Build a Startup. This is your weekly 1-hour show that is dedicated to the secret sauce, or like spilling the secret sauce of a successful startup. Like, for example, today we're here with Julien Simon from Arcee, ex-Hugging Face, ex-AWS, and here with my friend Nicolas. Nicolas is a senior solutions architect focusing on early stage startups in sub-Saharan Africa. We had a few very interesting episodes of this show. A few weeks ago we had Lovable. I'm going to share some of the links in here. Next week we're going to have Fireworks AI and Super Annotate. They will take us through the journey from annotating your first piece of data set all the way down to enterprise ready inference. But let's get back onto small language models with Julien and your demo. I would say, let's get going. And folks, if you have any questions, please use the chat box right now.
Yeah, go ahead. I'll keep an eye on the questions.
Absolutely.
Okay, so we're going to show you 2 demos, right? So the first one is our 4.5 billion model running on EC2. And recently AWS released a new family of Intel instances. I'll talk about them in a minute. So we're going to show you Intel EC2 inference on an Intel platform, and then I'll do the same on SageMaker. So the managed service for AI and ML, and we'll use a Graviton instance. Okay. So if you want to dive a little deeper, well, Giuseppe has shared some links, but you can go on the Hugging Face Hub. This is the model I'm going to be using. So AFM 45B, that's the vanilla model, right? So RCAI/AFM 45B. And this is the GGUF version. So that's the version optimized already for Llama CPP. Okay, and if you go to RCAI/blog, you'll find blog posts, and we'll tell you everything you need to know about AFM, why we built it, why we think it's good, benchmarks, etc., etc. Okay.
Yeah, I'm also sharing a lot of links on the chats right now.
Yeah, thanks, thank you. Okay, so first demo. So these are the instances I was talking about. So that's R8i. And they're the latest Intel CPU generation, the so-called Granite Rapids. Intel has those crazy code names that you haven't tried to remember. And so that's Granite Rapids. So that's literally the latest one. So R8i is the first generation. I'm sure we'll see C8i as always, and the other variants. But for now, that's what we have. Okay, and you can read this good blog post and learn about this. So that's what I'm using here, an R8i instance, and I've built actually. Let me show you this one. I've actually built a Docker container that makes it very easy to grab models from Hugging Face and run them with Llama CPP, either on EC2 or any Docker environment, and also on SageMaker. Okay, so that's what I'm going to be using here. If you go to github.com/Julien Simon, you'll find it. And if you like it, I'm always happy to see some stars. Okay, you have some test containers if you want to. You don't even have to build it. They're on the Docker Hub, so you can just go and run this in 5 seconds. And this is going to work on any Intel system or any ARM system. I'm actually using it on my Mac very successfully. Okay, so here, what am I going to do? I'm just going to run my container. I'm going to grab the 8-bit optimized model that you see here from.
What does that mean? I know it has something to do with quantization. Is that correct?
Yes, exactly. So this is an 8-bit quantization of the base model. Okay, Q8 means quantized to 8 bits.
And
Okay,
it means
so
that we are shrinking the depth of all of the
so
weights in the model.
Base
right?
models. Yeah, let me. You're right to ask. So the base model, when you see Hugging Face models, usually, well, not usually. I mean, they're all the time. They are in that format called safe tensors, and those models are trained in 16-bit precision. Okay, which means when we say 4.5 billion parameters, every parameter is a 16-bit value. Okay. So quantization is a process that will rescale model parameters to a smaller range. So when we say quantize to 8 bits, it means we're going to look at those 16-bit values and we're going to rescale them to 8 bits. So obviously the model size will be divided by 2. And you could say, well, aren't we losing a bit of precision there because there's so much granularity in 16-bit, there's not so much in 8-bit? In theory, yes, but 16 to 8, in my experience, is for models of that size, is completely invisible. If you go smaller, if you go to 4 bits, yes, it'll be maybe there will be a little bit of degradation, but again, from 16 to 4, the model is now 25% of the size. So it's a trade-off, right? The smaller you go, the more memory you save, but the more degradation you could see. So here, 8 is really safe. Okay, so this has been pre-quantized, and I'm just gonna run this thing. Okay, so the model, I already downloaded the model, so it's already in my cache, which is why it's super fast. Okay, we can see Llama CPP is detecting all those great instruction sets. If you're a CPU geek like me, you probably know those: AVX, AVX 512, AMX. All these are basically instruction sets to accelerate the typical math operations involved with deep learning and transformers. Okay, and I'm using 32 cores. Okay, so we loaded the model, and it should be ready to go. Yeah. Okay. So now it's running locally on this machine. And I can just use curl and use the OpenAI API format and say, okay, explain how the attention layer works in transformer models. And here we go.
So if your voice goes robotic, we know why, because you're ramming onto your CPU right now.
No, that's oh, sorry, I'm on the wrong port. That's why it's not starting. 8081.
No, are you running this on? Oh, of course, you're running this in the cloud.
Or is
How
it? Yeah,
strange.
of course, of course. Let me check. What did I run? I went too fast. I was talking. No, it's 8080. It should work.
Let's
see.
give it.
Let's
Let's
try
give it a few seconds. And folks, in the meantime, have you ever used a small language yeah, sorry, my voice is becoming robotic. Probably I'm thinking too much. Have you ever used a
there we
small
go.
language model before? Please let us know in all of the chat box. Sorry, there you go. Is it up and running now?
Yeah. So yeah, that's it. So
There
here
you
I'm
go.
using Perl. So there's no streaming, but you can see how fast this was. We have 30 plus tokens per second.
That's
right?
great. And
which is faster that you can read, right? I mean,
exactly.
if you use streaming, I mean, we'll use streaming on SageMaker. You'll see the difference. But yeah, this is really good. This is really good speed. Let's try that again.
And you're actually running it via. So what is the server that you're actually using? It's
so here
Llama
it's
server?
Llama. Yeah, I'm using Llama CPP. Okay. Okay. Yeah. So yeah, we have there we go, 31 tokens per second. Okay.
And no, I just want to stress this: no GPU was
no
harmed
GPU. That's
in actually doing this. So like this is let me go. This is a R8. What kind of
R8i?
Okay, R8i. Let me see if I can get the costs of it.
Oh yeah, I'll find out.
Yeah, because I just R8i.
I think it's I could actually see it.
It's $13 cents per hour for the small. But I'll find something.
I think this one is 4XL or 8XL. I don't know.
4XL.
I guess we have the pricing. Yeah, if blog posts usually pricing.
Yeah. So I'm looking at this is in US East 1, so North Virginia. I'm actually looking at Vantage, by the way. So it's $1.11 per hour on demand.
And those are the R instances, and R means RAM. I mean, that's how I remember them anyway. So they're the high memory capacity instances, and we can see this here, right? Like even R8 8XL, which has 32 cores, has 256 gigs, which is way too much for our purpose, right? So what I'm saying is we're paying for a lot of RAM and bandwidth, etc., that we don't need. So that's why I'm waiting for the C8i, which will have the same number of cores, probably the same clock speed, but they will have maybe half or quarter of the RAM, and so obviously they will be much cheaper. So the only reason why I'm using R8 here is because that's the only choice available to me. But yeah, so this means you can get good performance out of the box on this kind of machine. And honestly, you don't need, like, for a single session, you don't need 30 tokens per second. So you could actually run maybe 1, 2, maybe up to 4 sessions, depending on again how latency sensitive the use case is, in parallel, right? So it doesn't have to be just one user per server, obviously. Or you could say, well, I could run multiple models, which is a use case I love, right? I could say, well, I don't need 32 threads for this model, so maybe I'll just give 16, right? And then I have another model, maybe a model I fine-tuned, or maybe a completely different model altogether, and I'll give it 16 threads as well. So now you can run multiple models on the same instance. And maybe you can even run the application itself, right? That requires the models all on the same box. And of course, you can then scale out, right? Right now, if you look at the typical architectures for AI apps, I mean, you have an app running, let's say, on maybe a Docker container or a Docker cluster, and you have GPU endpoints somewhere, okay? So maybe they're dedicated, or maybe they're actually GPU instances in your Docker cluster, but they tend to become like a single point of failure, right? And so instead of doing that, it's if you have if you do it right, there might be a way to do away with the GPU instances and just scale your compute completely the same, whether you're scaling the app or scaling the inference, right? You can run, so in Docker terms or in EKS terms, you could scale your pods, your inference pods and your app pods on the same instances, regardless of, is it CPU, is it GPU, and because CPU instances tend to be cheaper, obviously, than GPU. I mean, you could probably scale bigger. And at the end of the day, $100 is $100. It doesn't matter if you're spending $100 in GPUs or $100 in CPUs. You just spend your $100 and scale out to the max, and get more parallelism and more resilience in a way. Because if you have one or two GPU instances in the cluster and they fail, the app fails. If your inference is running on your 50 nodes in a cluster, anything fails, you're not going to even see it, right?
Yeah.
So I think CPU inference is an interesting architecture. It's not, it's obviously it won't work for the crazy high scale scenarios where you do need GPU acceleration. But if you have cost sensitive and I would say, small to medium scale scenarios, I think CPU could really work.
And Nicolas and Julien, I have two interesting questions coming from the chat. So Ramesh was asking, what kind of small language model is suitable for architecture and MEP related projects? By the way, I don't know what MEP stands for, so Nicolas, if you can shed some light on it. And then there's another question. I'll bring it up in a few seconds.
So in my understanding, MEP is around mechanical, electrical, and plumbing. So anything that you do in design, installation, and potentially management of this. So the predictive maintenance parts that Julien mentioned earlier. So typically, I think Julien made it clear that the data part of the equation is super important. It's not 10%, it's not 20% of the problem. It's, I would say, a good 80 to 90%, right? And so in those scenarios, when you're dealing with architecture, when you're dealing with management of these type of systems, we spoke a little bit earlier about use cases where smart city and IoT devices would be super useful. Turns out one of our colleague based out of Dubai created a framework called the Garnet framework. I'll share with you the link in the chat. And that framework is a framework essentially it's open source, number one. And number two, it's made to build dynamic knowledge graphs. So ultimately, if you're wanting to build, let's say, I mentioned this earlier, but a digital twin of the building that you're managing, and you have all kinds of data around plumbing, around electricity, around mechanical stuff, then you can start making decisions at the edge. And so in terms of SLMs, I think Hugging Face had a very interesting blog published earlier this year around some of the popular SLMs like Qwen 1.5b or a smaller version of DeepSeek, maybe Gemma, also that were smaller. I'll share that link with you. But the combination of this framework and the right model, and of course, aggregating all of the data from sensors could be an amazing solution to deal with MEP for those projects that you're looking into, Ramesh, I believe.
Sounds great. That's
Yes,
Ramesh. I hope that answers your question. Julien, I just really want to go to your last demo because we are about to go to maybe the last 5 minutes, and I really want you to.
That'll be fast. So
yeah.
Okay, so now I'm using SageMaker, and if you've never heard of SageMaker, the 30-second pitch is it's a managed service for machine learning on AWS. It works with a Python SDK, the so-called SageMaker SDK, that allows you to fire up training instances, inference instances that are completely managed by the service. So unlike EC2, where you have to go and do the kind of setup that I did here, You just launch an instance and point at the right container, and that's about it. Okay, so very simple way to, particularly for deployment. Okay, so here I'll go quickly. The notebook. I don't think the notebook is on the GitHub yet. I'll probably write a blog post. So if you follow me, you'll see this one. So I'm using exactly the same container that you saw on EC2. The only difference is, of course, it needs to be hosted in ECR, so the Docker hosting service inside of AWS. You can't go and use external containers. I'm giving my inference endpoint a name. And this is the instance type I'm going to use. So this is actually Graviton 3 instance. I think Graviton 4 is now available on AWS and on AWS certainly, but I mean on SageMaker. But just to prove my point, I'm using an older one here. That's my Hugging Face token, which will be deactivated shortly because I'm using a gated model. And then, of course, I can deploy a model. So I can deploy it in different ways. So here, in the previous example, you saw me deploying directly the optimized model, right? We went and deployed the GGUF model directly. We see this here. So here, I'm actually going to deploy straight from the Safe Tensors model, right? So I'm going to deploy from the base model, and I'm going to optimize it on the fly, which I believe only my container can do at this point, which is why I built it. So this is the model I'm going to use. I'm going to quantize it to Q8, and I could, again, deploy an already quantized model, or instead of deploying from the Hugging Face hub, I could deploy from S3. Which is nice if you don't want to have a dependency on the hub, okay? So I create a model object with a container and those parameters you just saw. I'm calling deploy, and after a few minutes, I have a model endpoint, okay? And if I look at the deployment log very quickly, okay, we can see we're downloading the model, and we'll see the okay, let me scroll down a bit, and we'll see the quantization process, right? So we see quantizing the 16-bit model to 8-bit. So we see all the quantization layer by layer, okay? So doing everything on the fly, which is very nice. And now we're able to run inference. So let's go to streaming inference directly, which is always more fun. So again, I can use the OpenAI inference format, which the container supports. So why are transformer better models than LSTM? Explain step by step. Just go and run this, and you can see what kind of speed you're getting from this, right?
Wow.
Okay.
Yeah, there's virtually like no difference with running something on a GPU. Right?
No, and so this is again this is C7 8XL, okay, and that's a rather cheap endpoint. Okay, that's a rather cheap endpoint. You could probably go even lower. I think you could run on 4XL and it would still be very nice. And because it's SageMaker, you get all the goodies that come with it. If you want to do auto scaling on the endpoints, blah 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 blah, you can do that. So I think this is this is, I mean, nobody would argue this is too slow, right? I don't know how fast this is, but it's certainly 20, 25 tokens per second, something like that, and this is definitely more than you need. So again, if you don't want to use GPUs because they're too expensive, you don't need them, you don't have the crazy high scale that requires them, or maybe you run in an AWS region where GPU availability is a little bit difficult. Unfortunately, that's the case in some of the newer regions, particularly. This is a really good option. Okay. And I've been telling you since 2016, but please, when you're done, delete the endpoint and you'll stop paying, okay? If I'd gotten a penny every time I said that, I'd be retired. But yeah, I don't need pennies, but I want you to save dollars.
Yes,
So
absolutely.
please delete the endpoints.
Yeah, and so, folks, we're getting closer to the end of the stream, so thank you so much for all of this. Nicolas, I don't know if there's any link that I missed that I should be sharing. So there's Edward asking SLM plus graph. I need this. Is there any resource that we can share with that? Anyways, I will be lurking around on LinkedIn. Or just like hit me up, and I'll be super happy to get you in touch with Nicolas and Julien. So, folks. Again, thank you so much for sticking around. Another great episode in the archives, and you can have a look at all of our episodes on AWS events on YouTube. But last announcement for today: Julien will be in London on the 14th of October at the JNI Loft. So, folks, if you are around in London, please have a look at startups.aws/events and book your ticket. It's free to join, but we have limited space. It's not like Twitch. But then I think that's it. Please also make your way next week. I think 2 p.m. BST, 6 a.m. PST, and 9 a.m. Eastern time. We'll be talking about what it takes to go from data to inference with two of my favorite startups, Super Annotate and Fireworks AI. It was great to have you here, but if you have any questions, feel free to hit us on LinkedIn, and I'll see you next week. Bye-bye. Have a good one.
Thank you. Thank you
Bye.
very much.
Bye. Thank you so much.